In this video, I'm going to be downgrading the system firmware on this mid-2012 15-inch Retina MacBook Pro. Now, the only real reason that I want to do this is simply for cosmetic reasons. Now, I know that seems kind of ridiculous, but I personally think it is worth doing this, and I'll explain why in just a second. So essentially, for those of you who don't know, when any of these MacBooks are updated to version 10.10 Yosemite or later of macOS, they will automatically install a system firmware update that, I guess it probably adds native support to the system for Yosemite and later. But what it also does, and this is why I want to downgrade the firmware, is it changes the EFI boot screen. So as you can see here on this machine, I'm sitting at a black screen with my main hard disk shown right there, and I can of course click the little arrow or press enter and boot from it. Now that's normal, obviously. However, if we take a look at this Retina MacBook Pro, you can see that it is a white screen and has the old style drive icons here. I know I can't really show you exactly because this one doesn't have a USB drive plugged in it, but the hard disk icon, if this had an SSD in it, would also be the old style SSD icon. And of course, the main reason is because the screen is white. And I know, like I said, this seems kind of ridiculous, but since I primarily run OS 10.9 Mavericks on my machine, it seems kind of, it would be better if this machine just showed a white EFI boot screen, because the boot screen of OS 10.9 Mavericks is also white. So if I go ahead and boot from my main hard disk here, you can see why I would want this to be a white screen. So go ahead and select it here. And as you can see, then as soon as it starts booting, it just switches over to a white screen because, of course, Mavericks does not support the black boot screen. So go ahead and log in here. And as you can see there, it is just my normal Mavericks install. So let me go ahead into About This Mac here so we can take a little bit closer look at the system. So you can see that this is a 2.6 gigahertz Intel Core i7 with 16 gigs of RAM, and it also has the NVIDIA GeForce GT 650M graphics alongside the Intel HD Graphics 4000, as you can see right there. And for some reason, this particular motherboard has a late 2013 serial number programmed onto it. So I'm not exactly sure why that happened. I actually got this board for about $100 off eBay. It was water damaged and I repaired it. But I'm not sure why this must have been serviced by Apple at some point in the past, and they probably just programmed the wrong serial number onto this board. So I guess that's alright, I don't really mind it, but it is actually a mid-2012 and not a late 2013 model. So, like I said, we're going to go ahead and begin the process of downgrading the system firmware on this machine for no other reason than to get the classic white EFI boot screen and the classic style drive icons. So, like I said, once again, that is pretty ridiculous, but the process is relatively easy, and in my opinion is definitely worth it for my use of this machine. So, the first thing we're going to need before we get started is a flash drive or a hard disk that contains a copy of Linux. So I've actually already installed a copy of Ubuntu on this external hard drive here, this SATA hard drive that I have hooked up to my adapter here. So what we're going to go ahead and do first is I'm going to hook this up to this machine, boot from it, and then we're going to dump the stock ROM of this machine. And speaking of which, that is a requirement for this. Of course, Apple, being Apple, will not let you simply download and install an older system firmware version using the standard software update or the standard firmware update utility in the system. So I will have to do this through Linux using Flashrom. Now, of course, with that being said, we must have a source to get the older firmware version from, and of course that's where this machine comes in. Now this was another Retina MacBook Pro I got off eBay quite some time ago for only about $100 as well, and I got very, very lucky with this one because, like I said, it does have the old style, the Maverick style EFI boot screen. And this is very hard to come by. You will rarely ever see a Retina MacBook Pro still having this old firmware version installed. So, like I said, I got pretty lucky with this. And when I make a dump of this ROM, which we will need to modify a bit and then flash onto this machine, I will put it up on my web server, and I have a link to it in the video description if you want to download a copy yourself and modify it as I show in this video. Of course, this will only work on a mid-2012 15-inch Retina MacBook Pro and no other machine. So with that said, let's go ahead and get started by booting Linux on this machine, and then we'll go ahead and resume the video. Alright, so as you can see here, I've gotten Linux booted up on my Retina MacBook Pro. Of course, this is the one that I'm going to save the backup ROM from. So just in case something goes wrong, you know, I'll have a backup of my system ROM that I can just flash back on. So to do this, it's very easy. You do have to have Flashrom installed, as I said before, but if you don't, you can just install it using apt. So I have already installed it on this drive, so I'm going to go ahead and type Flashrom -R, which means read, and I'm going to save it as backup.rom. So we just go ahead and press enter on that. And apparently I need to set a programmer option, so I'm going to go ahead and get that set, and then go ahead and finish the process. So I'll be right back. Alright, so I think I figured it out here. So I just have to specify internal to tell it to use the ROM on the system motherboard. So I'm going to go ahead and run this command again. So that's sudo flashrom --programmer internal -R for read, and then the name of the file to read to. So I'm going to go ahead and run this command, and in theory it should work. And as you can see, it is now reading the flash. So this will probably take quite some time, knowing how these ROMs are. Oh, apparently not. So as you can see, we've got our ROM right here, and if it saved it successfully, it should be about 8 megabytes in size, because that's the size of the ROM on this board, and as you can see, it is. So that means we have a fully successful dump of the system ROM. So now that I have my backup ROM saved, what we need to do now is boot this machine off the same Linux drive and dump the old boot ROM from this machine. So I'm going to go ahead and get this computer booted up off of the Linux drive and continue with the process. Alright, so as you can see, we have the machine with the old boot ROM booted up into Linux now. So now we just have to do the same dump command like we did before to dump the ROM of this machine. So go ahead and type that in again, and of course it's saved in my history now. So for this one, I'll name it just old.rom, so I know that this one is the old boot ROM. So go ahead and run that same command and let it dump the ROM. So I'm not sure what this is about, but I'm not sure why this one isn't working exactly like that one is, but I'm going to go ahead and try to figure out this and go ahead and resume the video. Alright, so it turned out for some reason it wasn't able to get the exact model number of the flash chip, but I went ahead and specified the model here using the -C option right there, and you can see I just entered the model of the chip right there. And in theory, like I said, if this worked, we should have an 8 megabyte file, and we do. So that means the flash was successful, or the dump was successful, I should say. So now what we're going to go ahead and do is copy both those files to another flash drive, and that way we can transfer them over to a copy of macOS and use a hex editor to make the necessary modifications to this ROM to allow it to work properly on my other machine. So I'm going to go ahead and get these ROMs copied over, and then we'll begin the process of modifying this dump to work on my other machine. So I'll be right back. Alright, so I've now gotten both ROMs open in a hex editor here, as you can see. So there are two things that need to be modified in the old ROM to get it to work on my other machine. So the first thing we need to do is copy the ME region from the original ROM from my machine and put it into the old ROM. And the second thing we need to do is set the serial number to the same serial number that my system already has. So in order to do that, the first thing we need to do is go into our backup ROM. This is the ROM, like I said, I dumped from the machine that I want to downgrade the firmware on. So we're going to go ahead and do a Control F here, and we want to search for CRID, K-R-I-D, and this is going to find us it's a K-R-I-D, and this is going to find us the ME region in the ROM. So you can see it starts right here. You know where it starts from these first two blank characters here. So I want to go ahead and do is select the entire ME region. Now I've also downloaded a clean ME region right there, which we can use to figure out what the size of it is. So we could use this clean ME region if we wanted to. However, I'm not going to do that because, you know, I may as well use the ME region that was originally on my machine since I have it backed up right here. But we can see the length of the clean ME region is 17D000, which is just the hex value. So what we want to go ahead and do is go into the backup ROM, ensure we've put our cursor right at the beginning of the ME region, because you can actually see there's the beginning of the ME region there. And if we go up here, you can see that the beginning of the ME region is the same. So, like I said, we want to go ahead and select here, right-click, select block, and select the length tab, and then we want to enter that same length. So that was, if I remember correctly, hold on, 17D000. All right. So we want to select block length, and then 17D000. Just like that. Go ahead and select OK. So now we know we've highlighted our entire ME region. So now we can go ahead and Control-C, copy, go into our old ROM, find the same ME region. So Control-F for CRID once again. There's our ME region here. You want to go ahead and right-click, select block. Make sure we set the same length as we did before. So that was 17D000, just like that. Select OK. Now, just do right-click and select Paste Right. So that will overwrite the ME region with the ME region I took from my backup ROM. So now what we can go ahead and do is save it. And now it is written. And now we have the ME region from my system on the ROM from the other machine that we're going to be flashing onto it. So the last thing we need to do is change the serial number. So let's go ahead and locate the serial number in the old ROM, the old firmware. Let's go ahead and Control F. And normally I find serial numbers by just typing in C02 because that's what they normally start with. And if you can't find it the first time, just search it again. And eventually you will find it. There it is. See where it says SSN right there? That indicates that the serial number is right here. Now, of course, this is the serial number we're trying to overwrite, so we can just ignore that for right now. So we need to go into my backup ROM and locate the serial number in this ROM. So go ahead and search CO2 right there, and look at that. There's my serial number from my other board. Go ahead and copy that. Right-click here and select Paste Right. And now our serial number has been changed. So this is now the serial number that my system originally had. So we'll go ahead and save it again. And now we have the ROM completely modified and ready to be flashed. So we can go ahead and close that. I've got the ROM right here. You can see the old .rom file that I just saved there is still 8 megabytes in size. So that means it is still, we did not remove or add any bytes. So we can now copy this back to the flash drive, boot back into Linux, and flash it onto my system. So I'm going to go ahead and get that ready to go and resume the video. Alright, so as you can see, we are back in Linux, and I have copied the modified ROM right there. I went ahead and renamed it to old-modded.rom. So I don't know that's about. But as you can see, I have our Flashrom command already typed in here. So it's basically the same thing, but instead of -R, we are using -W, which means write, and then specifying the name of the file we want to flash. So with that all put in, let's go ahead and press enter and see what happens. Let's see. Alright, so it looks like my ROM has some sort of lock on it, so I'll have to figure out how to unlock that. And then, hopefully, once I figure that out, we'll be able to flash it and get the system downgraded. Alright, well, unfortunately, as you can see here, the flashing actually failed. I had to force it because apparently this has SPI protection, which I didn't know, and it failed, so that's unfortunate. So now what I'm going to have to do is I'm going to have to disassemble the machine and flash it using my EPROM programmer externally. So I knew this would probably end up happening, but yeah, so I do have an EPROM programmer, so that's no big deal. But if you're trying this yourself, I would definitely not advise doing it this way. I would definitely make sure you have an external EPROM programmer just in case something like this does happen. So yeah, unfortunately the flashing failed, so I'm going to go ahead and shut my machine down, and let's go ahead and actually see if it boots back up. I doubt it will, but let's see what happens here. Alright, so the system's off now. Let's go ahead and turn it on. Oh, and it actually is still working, so yeah, that's interesting, I guess. So yeah, maybe it's because this firmware supports system integrity protection, and that could be why it wouldn't let me flash. So now that I'm able to get into an OS now, I'm going to go ahead and disable system integrity protection and try it again and see if it works then. So I'm going to go ahead and try that and resume the video. Alright, so unfortunately, even after multiple attempts, I was unable to flash the ROM correctly with Flashrom and Linux. So as you can see here, I have ended up desoldering the EPROM so I can program it externally using my EPROM programmer here. So now that I've gotten the EPROM out of the board and into the programmer, I can go ahead and plug the programmer into my machine here. And then we can begin the process of programming the chip. So as you can see, I have the software open here, so we'll go ahead and detect the flash, and not sure why my EPROM programmer isn't working correctly now, but I'm going to go ahead and figure this out, and then I'll go ahead and resume the video. Alright, so I got the EPROM programmer to detect the ROM. It just turned out it wasn't pushed in all the way, so go ahead and detect the flash again. You can see it detects it just fine now. Select, and now we're just going to go ahead and read the chip. So I'm just going to take another dump. Even though I already took one using the Flashrom and Linux, I may as well just take another just to be certain that that dump was good. So I'm going to go ahead and let this finish dumping, and once it finishes, I'll go ahead and resume the video, and then we'll begin writing the modified ROM onto the chip. Alright, so the ROM has been dumped successfully, and I've gone ahead and saved it to my desktop now. So now what we can go ahead and do is open the modified ROM. So go ahead and open the modified old boot ROM right there. Go ahead and open. And now what we can go ahead and do is click Device and Program. So what this will do is it'll go ahead and erase the ROM and then write the modified dump onto it. And then from there, we should be able to solder it back on the MacBook Logic board, and it should now have the old version of the boot ROM. So I'm going to go ahead and let this finish writing, and once it does, I'll go ahead and solder it onto the MacBook motherboard, and we can go ahead and give it a test. So I'll be right back. Alright, so I've just finished soldering the EPROM back on the MacBook Logic board, and as you can see, I have fully put the board back in the case and fully reassembled it. So let's go ahead and turn it on and see what happens. And look at that, that is beautiful. A nice white boot screen. And Let's see if it loads my hard drive here. Yep, look at that. We've got the old hard drive icon back. Let's go ahead and boot from it. And as you can see, the system still boots perfectly fine. So that is the downgrade process of the system firmware, simply to get a white classic Apple boot screen back. Probably a bit too much effort put into it just for that, but yeah, nonetheless, it does work. Just to show you that now both systems have the white boot screen on them. Go ahead and restart this one. Turn this one on. You can see that one also has the white boot screen still. And that one does as well. So yeah, as you can see, now we have two Retina MacBook Pros with the classic white EFI boot screen. So yeah, that is the downgrade process of the EFI firmware on this Apple MacBook Pro Retina. So, hope you enjoyed this video.